Can you restart? Okay, yes. So this is Python music. This is the code that was written to like play all the music. Yeah. So yeah. So in case you were wondering, was I getting music from somewhere or actually writing code and playing the music? It was actually written code that was playing the music. Yeah. So yes. Okay. So yeah. So let's start off with the role.
I was trying to make it bigger for everyone. It's okay.
Okay. I mean, can everybody see that?
No, it doesn't work.
Hit one.
See, on top left, there's an
Yeah.
example, hit
Yeah.
the JEF,
Uh-huh.
and hit preferences.
Uh-huh.
Yeah, just trying to go.
Okay.
Oh,
Okay.
maybe 16 rows.
Yeah, okay. Okay. All right. Thank you guys. Okay. But anyway, but let's continue. So yeah. So let's start off with roll your boat again. So yeah, so as you can see, I included flute, trumpet, clarinet, and anything, and all the pitches and the durations in order to create this wonderful sound. So yeah. And so the next thing that I'm going to talk about is arpeggio, which are broken chords. Does anybody know who that is? No? Does anybody here play video games? You know who that is?
He's from Sly Cooper. I don't remember his name.
Sly 2, Band of Thieves. That's arpeggio.
Okay.
Yes. Okay, so arpeggio, he was a parrot, an anthropomorphic parrot, an animal that acts like a human being, or human being-like qualities. What was it? He was very smart, but he was very disabled, so he couldn't grow physically, yeah. So he decided to become evil and wanted to get a pair of robotic wings from a robotic owl in order to become great and destroy the world, yeah. Yeah, that is until his assistant triple-crossed him, possessed the robotic body, and crushed him to death. Yes. So we're yeah. So we're going to play this in honor of arpeggio. So yeah, so this is the arpeggiator, and I'm going to play some broken chords. Okay, so enter a note, C3. Let's repeat it 6 times. Let's try it again. How about D1? And repeat it 9 times. And let's try once more. How about F5? And let's do it 4 times. Yeah, so yes. Okay. That was a great tribute, right? Yeah, to arpeggio, the day. Yeah, video game character, right? Okay, yes. He will be proud?
Yes.
Yes, that's right. Okay. So moving on, iterations in a list. So in Python, iterations are pretty much repeated set of instructions, and lists are containers of data, which can be ordered and you can change it. So I'm going to do a demonstration of a repeated instrument generator. And also, does anybody know who that is?
Ben 10.
Yes, Ben 10. What's the name of the alien?
Yeah.
Echo Echo. So he has the power to split himself, clone himself, and do sonic shrieks. Yeah. Yeah. Come on, does anybody watch cartoons or play games or read comic books here? Yeah. Yeah. So MIDI instrument, let's say and B3. Yes. So what I just did was in a list. So I chose a random musical instrument, and when I put in, it prompted me to put in how many times I want the note to repeat, and I put in different notes, and it repeated for that many times. So this is like a symbolism, a symbol of a representation of the notes that's been played. And as you can see, it was repeating itself through list. Yes. Okay. So randomness. Life is all about randomness, and we all do spontaneous things. Like, how many of you guys here are spontaneous? No, you can't be a human being if you're not spontaneous. No, raise your hand up. Everybody here is spontaneous. Random things happen to you. It's life, good, bad, silly, whatever. Yes. Yes. Who isn't spontaneous? Okay. Yes. So that's Mozart, one of the greatest composers of all time in the world, and he created a theory, a concept called musikalisches Würfelspiel, which is German for randomness, for random music. And he created a game based on rolling dice. Every time the dice would roll, a different sound would play. And so let's try his 16 measure waltz. And just a fair warning, I'm about to do some simulated gambling here, so please do not report me, please don't tell the cops. Everything that I'm doing is within this room, okay? You guys got that? Okay, okay. I hope there's not a hidden cop in the room, okay. There's the code. Let's try it again. So those are all the choices, and it's being measured. And we roll the dice, and based on the choices that the computer randomly generates, it plays a note. Let's try it again. So do you guys notice the difference between the songs that are played? Cool. So, does anybody know what wind chimes are? Okay. I'm sorry?
Those things.
Yes, that's right. Yes, but human beings, we don't know everything. So I'm going to carefully explain what wind chimes are for people who don't know who wind chimes are. You never know; somebody may have never seen wind chimes before in their life. No, I'm just kidding. Everybody knows what wind chimes are. They probably seen it in their lives. Yes. So you know we can manipulate randomness. We can manipulate just like how we can manipulate our lives and how anything happens to us. You know, life is 10% what happened to us, but 90% is how we react to it. How do we react to certain things? How do we react to randomness? Do you just accept it and move on, or do you try to change it? So they can be applied here. So as you can see, as the computer goes through each item in the array or list, it plays a random notes of wind chimes, and it puts it all together in a sequence in order to play the wind chimes, which is how wind chimes are being played. When the wind goes through it, pieces of the wind chimes, smash against each other and create a sound. So that's what I try to emulate here. So pentatonic melody. A pentatonic melody is a musical scale with 5 or more notes. Does anybody know who that is? You know? It's Pentatonics. It's a well-known band, and they sing really good. I really wish I had their voices. Yeah. They sing like angels. So I'm going to play a pentatonic scale. So pretty much the pentatonic scale, I gave it a list of notes to put within the list, and that's the duration. So the duration is like how far apart between each musical note, whether it be an empty space, whether it be pauses, and put that in a phrase, and the computer goes through the containers and it plays the song that we just now heard. Okay. So yes. So I'm going to continue doing the simulation of gambling. Please do not report me. Okay. So yeah. So throwing virtual dice, musical notes playing randomly based on the results of the dice. And by any chance, does anybody know who that is? No? Come on. It's a video game character. Kingdom Hearts. Kingdom Hearts. Does anybody play the Kingdom Hearts series? No? Oh, okay. That's one of the villains from the Kingdom Hearts series. His name is Luxor. He has the power to manipulate time, but his weapons are dice and cards. And he can turn his victims into dice or cards. Yeah, he likes to play games based on gambling. Yes. Okay, so let's play it again. And again. Okay, so between those songs, it was played differently. And, did you all notice that? So that was based on like the computer, virtually it's rolling dice, and based on the outcomes of those dice, it plays a different note. Yeah. And you see all those ifs and else's. So that's just based on the notes that we play, based on the numbers on the dice. Okay, does anybody know who that is? Oh, okay, if you guys didn't say anything, you said what now? Oh, okay. Okay, if you guys don't know who that is, I'm about to have a fit. Okay, okay, yes. Okay, but anyway, SpongeBob SquarePants, there's a video game called Battle for Bikini Bottom, one of the best video games ever. It's going to have a remake coming up this year for the PS4. So yeah, that's one of my favorite childhood games. But anyway, there's a boss battle music, a mini boss battle music that you will hear if you fight any of these three characters: King Jellyfish, Prawn, or the Flying Dutchman. Yes. So I'm gonna play this. And I want to try to emulate it. Yes. So does that sound very similar to you all? And please be honest, does it sound similar or no? It's a close emulation. Okay, okay. Okay. So now, does anybody know that? Who said Sephiroth? No. The door's right there. No, I'm kidding. Okay. Well, that's Cloud, who's kind of related to Sephiroth when you think about it, if you play the game. Okay. I mean, he has Sephiroth cells, Jehovah cells in him. Genova cells, I'm sorry. So yes, so Cloud, he's from the video game Final Fantasy VII, which is going to have an awesome remake coming up this year. And does anybody remember the iconic part where Sephiroth killed Aerith? Yes. Oh, I'm so sorry. Okay. Yes. So for those of you who do not play the video game, a very important character died, and this is her theme song. Yeah, just when it was about to get good, huh? Okay. Okay, but moving forward, so I'm going to play a song. I'm going to play a piece of music that's similar to it. So yes. So this is based on this piece of music is based on how planets are in orbit and how they orbit around the planet Earth, and also their distance between each other. And that reminds me of Final Fantasy VII because it took place on the planet. Yes, that was the name of the place they were living on, the planet. And they utilized the energy of the planet called the life stream. For those of you who aren't familiar with the Final Fantasy VII mythology, so I'm going to play this, which is similar to Aerith's theme song, in tribute to her death. May she rest in peace. So that was me trying to emulate that. I mean, close enough, right? Okay. Sonification, the process of turning things into sound. Has anybody ever read Moby Dick? Okay, want me to spoil it for you guys? Okay, so basically, no, I'm kidding. Okay, yeah. So we're going to convert text into sound. So the computer's processing it. So it converted the entire sentence into sound. Can you all see that? Yeah. And that was the last sentence in Moby Dick. Yes. Okay, vowel signals. Now, I need a volunteer because I want you to try something. Any volunteers? Okay. How about you? Okay, come on. No, I'm kidding. I don't need a volunteer. I was just kidding. So we're going to try. We're going to try and convert heartbeats and bioelectricity into music. Okay. Okay, so pretty much, I just put the sound of a heartbeat and bioelectricity within a text file and put that in this code and assign the pitches and durations and the notes to it in order to play that sound. Okay, now let's convert images, the pixels within images, into music. Well, okay, moving forward, pretty much, I converted pixels into music, and based on how warm the pixels are, it'll play music very quickly. But if it was cool music, pixels that are cool like blue or purple, it'll play slower music. Yeah. Now, does anybody know who that is? That's Aerosmith, a very popular rock band, and I'm going to show how you can modify pitches using Python. Now let's change the frequency. It sounds like a banger, right? Okay. Yeah. Okay. So with Python music, you can do all of that. Modify pitches, have a virtual piano, live coding, all that good stuff. So yes, now let's convert math into music. Life is just full of ups and downs. Yeah. Okay. Does anybody know who that is? Oh, it's Finn and Jake from Adventure Time, a very popular cartoon. So yeah, so recursion and technology, that's when the program calls upon itself, and it just runs itself through multiple times. And now I'm about to show you a big surprise.
You only have about 1 minute.
Okay. This is a musical sphere, and I just wanted to show you guys that we all have music inside of us. We all have a light inside of us. And my philosophy is don't ever let anybody take your music away from you. As human beings, we all have different music playing inside of us, like fingerprints, DNA. We all have something unique about ourselves. Keep being great, keep being yourself. As the world turns, music will always be played. You can ask me questions at the end of this presentation. And these are the resources that you can use to learn Python. And you can try a YouTube video, a series of YouTube videos by the New Boston, one of the best coding teachers ever. And that's the book you can buy in order to learn more about creating music with Python. Again, my name is Hervé Niglo, and thank you all for attending my presentation.